So when you want to anti-differentiate some trig functions, namely sine and cosine, then you can use this rule over here. But a few things to note before we actually try some examples together. So first of all, over here, this bracket, these two brackets must be linear in nature. So if you have a quadratic there, for instance, then the rule would have to be a little bit different. You can't actually apply any of this. It'd be a little bit more complicated. Also that when you differentiate a trig function, instead of multiplying by the derivative of what's inside, you want to be dividing by the derivative of what's inside. So we know the derivative of what's inside is a in both cases, and we're going to be taking 1 on a instead. Also, we know that when you take the derivative of trig functions, you just change from cos to sine or sine to cos. In this case over here, it's the same thing. It's just that when you go from sine to cos, this is when you change to sine. You have a negative over here, so be careful of that. So that's only when you anti-differentiate sine. And as usual, just remember that make sure you add the constant over here when you take the antiderivative of any of these trig functions, or anything for that matter, as long as it's an indefinite integral. So first example here, you want to anti-differentiate one term at a time. So for the 2 cos 3x minus 2 over here, you can say that first of all, you're going to get, well, you have a 2 in front, so there's a constant in front of something you want to anti-differentiate, just take it to the front. It's multiplied by, now cos turns into sine, the sign doesn't change. So we have sine, and of course, the bracket doesn't change either. Note over here that if you have ax plus b, it stays the same. So it's one more thing to highlight, I suppose. These two, I'll just get a different color, it's a bit faint. So these two over here are the same. Okay. And what's in front is 1 on a, so that's just the coefficient of x, or the derivative of what's inside the bracket. So it's 1 on 3. And this sign over here, the sign turns into cos, but remember that the sign changes. If you anti-differentiate sine, it's going to turn into negative cos. So we have negative 6, which is what's in front, multiplied by 1 on 2. And sine is now cos. 2x stays the same, and add c towards the end. From here we can simplify, so we get 2/3 sine 3x minus 2. 6 times half gives you 3. Cos 2x plus c. For our next example over here, now we usually have it in the form of ax plus b. Now to avoid any confusion, you can just rewrite this before we proceed. This is actually equal to the integral of, you can put the half in front if you want, doesn't really matter. But what's inside the bracket is now negative 4x plus 7. So this is another way to view the trig function that you're integrating. So it becomes an even simpler problem now. So it's half multiplied by, now we anti-differentiate sine, you have a negative 1 on a, which is negative 4, cos negative 4x plus 7 plus c. Okay, so of course these two over here will get cancelled out with each other. We have double negatives, so we end up with 1 on 8. Cos negative 4x plus 7, you can say 7 minus 4x if you want, but don't really see the need to change the order once again. And that's what you end up with. Right. So since we've learned a couple of techniques from above, you can try this one yourself. It pretty much incorporates everything we've just tried out. So just pause the video here if you want to try it out yourself, otherwise we'll go through it together. So over here, differentiating the first part, it's going to give you -2 multiplied by negative, because sine will turn to cos, but you take the negative version of that, over a is 4, cos of 4x plus 1. Okay, and if you're running out of room, just go to a new line. But we're still working with the same expression. So we have 3 times, so we have 1 on, what is it over here? A is -3, so a is always the coefficient of x, -3. The sign doesn't change, so I'm talking about the plus or minus sign. From cos to sine, this stays positive up here. So you have sine of the same angle, which is 5 minus 3x plus c. Just to simplify this a little bit, double negatives, -2 times -1 gives you +2. And you can say that these two can be simplified down. So you have half cos 4x plus 1. Over here you have -1, where you have 3 times -1/3, minus sine 5 minus 3x plus c. And this would be your antiderivative of this expression up here.